Today I'm going to be your host and the producer, and Sagar is going to be the presenter. We're still following through with the whole e-bike sort of storyline. And what we're going to talk about today is we're going to talk, Sagar in particular is going to talk about some motion simulations and basically how to make the ride less bumpy. And for me as a mountain biker, I'm all about trying to make my ride a little bit less bumpy. So again, please like and subscribe, share it with your friends. Let us know in the comments, what you'd like to see coming next year. Again, we have our own agenda of things we'd like to discuss and chat about, but we're always open to hear, more importantly, what you guys would like to see from us. So without any more blabbing on, Sagar, let's get going. Yeah.
Yes, sure. Yeah, so just a disclaimer, as I'm not the motion expert guy. Basically, I'm a mechanical engineer with a structural simulation background, and I I learned motion simulation techniques and the tool from the platform in past few days only. So, but it's very easy to use. It's very easy to learn and analyze your mechanisms. So, I would really say that if I'm able to perform the motion simulations, then you can as well. The ritual, the best. I mean, we are doing we are bringing all the experts from the different domain on this web series on this series of YouTube live, but this time I'm the guy who will talk about the motion simulation. uh, so in general, so Greg, as a design and simulation person with a mechanical engineering background, I think you will be agree with me on the thing that when it comes to design, when it comes to your product, visualizing how your product will behave in a different scenarios is very crucial. And there are simulation tools comes into picture. So for motion simulations, we have dedicated role called 3D motion simulation, 3D motion creator role. Just like for other domains, we have different roles, which provides a robust set of motion simulation tools within highly interactive and tightly integrated motion to design environment for a true lifelike experience. And it also provides easy to use functionality for kinematics and dynamic simulation analysis of assemblies. uh, so you can analyze your mechanism, you can verify product range of motions and optimize your product from anywhere at any time, as it runs on a cloud-based 3D experience platform. So in short, it's super easy. Where I would like to, I mean, I just have explained my experience. So if I'm doing that, I'm able to learn this motion simulation so far. So I'm inviting you all to learn this app. And the app we will be using today is Xmotion Design app, which itself is a web browser based app. So it's very easy to access as well.
I think that's a key component is hopefully as folks have watched this whole webinar series, you've seen how easy the software really is to
Yeah.
use. And like you said, I mean, you're not a motion expert, but I mean, the platform, but you were able to just get in there and do some motion studies. And,
Yes.
that, we have Abacus technology for simulation. We have some CFD technology in there. And that's a huge item with 3D experience in general is how easy everything is to learn and how powerful it is, but also how connected all the
Yes.
components and all the different
Yes.
simulations and design and everything is. So, yeah, very, very nice.
Yeah. And when we talk about the motion simulation, yes, there is a lot to talk about this topic. But in the interest of a time and the scope of this session, I will not go in deep concepts.
Yeah, yeah,
So we will touch base on a few basic terms, basic concepts of a motion simulation and the tool. So basically, when you think about the motion simulation or motion study of any mechanism or any product or any assembly for that matter, immediately you will think of static, dynamics, or kinetics or kinematics. So all these terms are related to motion study, motion simulation, and all these terms concepts are very simple. But at the same time, I when I was in college, when I was during my graduations, I used to confuse with all these terms. So let me talk about these first, and then we will jump into the actual XApp, X Motion Design app, and we'll start on the motion simulation. So, so basically, what is the? I mean, there is a separate branch of a physics which study all the motion of objects in our everyday life, called rigid body mechanics, and uh, one can divide these into two subfields, I would say. First is a static, and the second is a dynamics. So static studies objects that are either at rest or in a constant velocity, and dynamics basically studies objects with the acceleration. So furthermore, if you divide the dynamics into, then it's like a kinematics and kinetics. So basically kinematics is a motion of the object, where you will get details of a motion, which describe the motion of the object, like velocity or any position kind of thing. Or in kinetics study, we expect for the forces, or what is the cause behind the change of a motion. So that's the brief or major overview of these terms. So going to the actual session, i I'll share my screen. Okay, so right now, you're seeing, I mean, this is the actual UI of the XMotion Design app, where you will see several components over there. So XMotion Design is an application within the 3D motion creator role, allowing you to simulate rigid body mechanical movement in assembly structures. Then it works best with existing assemblies. If you have assembly created within the 3D experience applications such as XDesign, the XMotion will work best. I mean, there will be a proper collaboration between when you transfer your assembly from XDesign to XMotion, you will get all the products as a CAD parts, then their material and all the mates within it. So it will be very easy for you guys to simulate the mechanism. But if you are importing your CAD model from other CAD applications, then you need to define material and the mates or the joints, so that mechanism can run. So that's that's one thing to think of. And then now let me take your attention to some of the basic things. So so most important, when you import a physical product, the XMotion will convert it into mechanism. You need to then define the mechanism, mates, joints, and then you can set the analysis and run the analysis. So within the mechanism, you can add bodies, then joints, contacts, springs, forces, or drivers of a mechanism, to make your assembly behave as it would in real life. So and when you finish up with the defining mechanism, after that you can perform a dynamic or a kinematic analysis. So these are the this is the basic, or the top high end, or the helicopter view of the total motion simulation. So now let me explain you what is there in the this UI.
So this worked on a SolidWorks part, right? So this doesn't have to be like native 3D experience. This could be a SolidWorks part, right?
Yeah, so currently this is the SolidWorks part, and SolidWorks assembly, I would say. So it is not having any mate over here, but if you used XMotion, XDesign to design your assembly, XDesign is another app, web-based app, where you can easily design your CAD. So if you are using that app for your mechanism design, then directly it will import all the material, all the mates. So it will reduce your work in Xmotion Design app. So I would like to take you to this attention, your attention to the left part, where this is the design manager. So in design manager, so what it does basically, so it stores and organize a study data in a tree structure. So it's like having your physical product first, then the mechanism, then the scenario stuff where, yeah, analysis case, and then the your analysis step will be there, and after that results are stored. So this is a structure where, from where you can easily access each of body or joint or contact thing, or any feature of a mechanism. Then in the bottom, in the middle, you can see that there is an action bar. So basically it's a group of available commands organized with the tabs. So under mechanism you will see uh, different commands where you can define the join, define marker, then initial condition. You can run the mechanism just to make sure that every mate is defined properly or not. Even you can submit run by hitting simulation after you are, if you are okay with all the things, all the mates, all the joints within the assembly. So this is particularly the main UI of the mm, okay. So let me explain another thing, the very important thing, that under mechanism you will see bodies, joints, initial conditions, contacts, machine elements, where, let's say, if I hit the bodies, you will see the geometry. If I select it, it will highlight the corresponding geometry, corresponding physical product. And if you go inside it, you will find the markers. So these are the markers. You need to be very specific with the markers, because to define a joint, markers or body, both are the alternative options. But if you go with a marker, then it will make your stuff very easy. It will be very clean and clear for you guys to understand how to set up the mechanism. So let let's start with the actual.
So is that much different than just setting up like assembly relationships? So when I'm in 3D experience and I'm putting parts and components together, and I'm putting the wheel axle in the center of the fork, or the rear triangle. It looks like it's a pretty similar process.
Yes, exactly. In this particular app, you just need to make sure that the orientation of your marker is in the same way. I
Okay.
mean, x-axis should be aligned with the x-axis of the next component or the other component which is involved in the joint.
Okay.
If it is not, then your assembly will be in a mesh. It will automatically get rotated, and that's why you will see the trouble. So
And so if I'm so you're doing this on a SolidWorks part or
yeah.
assembly that's brought in, and if I was to do this on a native 3D experience assembly, and I used assembly relationships as I'm putting that together, I could probably reuse a bunch of those, I imagine.
Yes, exactly. All the made or all the interrelations will be directly transferred to the X motion design. All the
Okay.
material will be transferred to this. So there is an advantage. I mean, when material and your joints, your mate or interconnections get transferred to the X motion
Uh-huh.
design app, the mass related to that particular product, then the center of mass, then inertial property, and if that particular product or that body is fixed or free to move in mechanism, that will be automatically identified. So
Okay.
that's the advantage of using native 3D experience, native geometry.
Cool.
Yeah, so let me see what happens. Okay. So when you import a SolidWorks geometry, SolidWorks assembly, yeah, and the most important thing, to run a motion simulation, it is mandatory that your assembly there should be an assembly. You cannot import a part into Xmotion and then try to uh, work on the mechanism for that particular part. Single part cannot form a joint, or I mean a mechanism. So please try, I mean, make sure that you are importing assembly in first place. So right now I have imported, oh, I have imported the e-bike assembly, and essentially this is not the actual mechanism, type of mechanism. It's I'm simulating this just to have a motion simulation, motion between the suspension forks. So that's why I have imported this assembly. So right now I'm having ground as a part. So I will drop this cycle from some height, and then it will bounce back as a suspension fork are there. Then I'm having rear wheel, bike frame, then suspension fork, upper suspension fork, lower suspension fork, front wheel, and the handlebar or free ride bar. So right now, if you are observing these XYZ components coordinate system, these are nothing but uh, the markers. So let's so originally with the body, markers are nothing but the coordinate system associated with your particular product or the object. So here, as I import the assembly with this particular physical product, the ground, the the body reference marker is already there, and I have defined this one for my mechanism to make it very smooth and happening, I mean, as I expect. So that's why you can see several markers, you can create several markers inside the body to define joint properly. So I have gone through, I mean, now you can go to this model assembly or the products, where you can click on particular part, and you can unhide it, hide it. Then you just need to go to the mechanism tab, and there is a command called marker. You can click on that. A message or a window will open where you need to select the body, where to add the marker. So body section is this one. Right now I'm interested in adding uh, adding marker to this frame. So I'm selecting e-bike frame, and then it will again ask you for a manual and by geometry. So it's easy to go with this option by geometry. So I will select this one, and then you can see where to place the origin. I will be interested in this particular region, so I'm using this edge. So you can here see that the marker is there,
Hmm.
right? But the orientation is not as expected. I mean, the original x is in this direction, and right now my x is in directing upward, so I need to move it. So if you closely observe, there are these circles or arrows which allows you to rotate it. And when you bring your arrow in the white circle, you will get the actual angles. So I'm rotating it by 90. So now x is aligned, but z and y, they are not aligned. So here again there is an option, flip primary direction. If I flip it, it will, so now you can see that x, y,
Yeah.
z components are aligned. So this is the way you have to define the marker. So right now the original marker was of wheel, which is in the same orientation of e-bike frame, where the rear wheel is joined. So if you hit this one, then there will be a marker added in the bucket of or under the e-bike frame. So this is the latest one. And if you want to edit it, just click on it. There is an option, edit feature, and you can go to the dialog box where you can edit the orientation and everything. One more thing, under this, you can easily delete it or deactivate it. We prefer to deactivate it, not to delete, because in future you might need that particular marker to
Mm.
define proper mechanism. So both the options are there. So right
And
now,
I assume these markers that, I mean, the purpose behind having these markers is when you start to define the mechanism relations, is you need some vectors or you need some planes so that you can
yes,
define
yes,
angles and things like that, so that you actually have these markers. So when you set up the mechanism relationships, you have something to actually point to that
yes,
is
yes,
very
exactly. You got
controllable.
it right. Yeah, yeah.
Okay,
And additionally, let's say, so now this, the name of this marker is marker by geometry point 4, but here you can see the field rear, upper suspension fork. So easily you can edit the name of this as per your convenience. So just to avoid the confusion, I mean, under this body, marker by geometry point 4 will be there. Again, if you add fourth marker under any other body, so right now suspension fork lower is having three markers. If I add fourth one, then the name of that fourth and this fourth will be the same. So just to avoid confusion, you can rename it as per your convenience.
cool.
So right now I will be deleting this. So this is how you create the markers and the body. So now we are done with the marker. Once you finish with your marker, so right now I have hide the rear wheel assembly. I will unhide it, and once you refresh it, it will be back in the right position. So I will not do that now, but after that, when you come to design a joint, so under mechanism only, there is next to markers there is a joint command, and when you open the joint, you will see a several type of joints. So fixed, rigid, then revolute, prismatic, screw joint, cylindrical, universal joint, planar joint, spherical joints. So most of the type of joints are covered in the X Motion Design app. So any mechanism you can easily easily simulate using XMotion Design app, as we are having a range, wide range of joints. So now my intention is to drop the bicycle on this floor as a ground on ground. So I wanted to fix the ground. So I have used joint fix on the ground. Then obviously there will be a revolute joint between rear wheel and the frame, and then front wheel and the lower part of the fork. So I have defined revolute joint and a revolute joint between these two. So let me show you how you can define revolute or any kind of a joint. So simply go to the joint command, select whatever joint you are interested in, then it will ask you for first geometry or a marker, then the second geometry or a marker. So this is the thing where markers are in a play, or are playing very much important role. So let's say I want to select a marker of a rear wheel. So I have created rear wheel centers, so that just for my convenience. So I'm selecting this, and then the second part will be of a where you are going to join that particular component or the part. So I'm going to join it to the bike frame, and I have created a marker for a rear wheel as a rear wheel. So I will select it. So it will appear over there, and even you can freeze the degree of motion. I mean, how much angle it should be revolute, by how much angle. So you can set minimum and maximum values over here, and by simply clicking on this OK button, that joint will be defined. So similarly, you can define whatever joints you want to have in your mechanism. So let's talk. So we discussed about joints. Then regarding initial condition, so initial condition is something before that. Let me talk about contacts. So contact will help you to identify which parts are they're contacting each other in mechanism. Usually that happens, so you can simply click on this 3D contact command. You will see that there will be, you can create one list or the two list. So let me, I will prefer two lists, because the one part is moving, the one whole assembly, the cycle assembly is moving, and the ground is fixed. So that for that, I will be creating a contact list of bodies where contacts are there. So rear wheel and front wheel, both the wheels are in contact with the ground. So I will be adding contact list first. I will be adding rear wheel and the front wheel in the contact list 1, and then for contact list 2 you can select for the ground. So just like this, you can clearly identify which two different list will be there according to your mechanism, and you can add respective components to the list. And then this is the important thing, where mesh density is defined. So mostly I prefer 40 to 50 range, but depending on the solver time, I mean, if your mechanism is way simpler, you can go for coarse mesh. And if your mechanism is with a fine or small components, then it is recommended that you should go with the fine mesh. And just click on OK button. The contacts will be defined between your mechanism. Then after that, you can define drivers. I mean, in some mechanisms, there can be a motor driver or a chain drive or belt drive. So you can offer that kind of a drivers in your mechanisms. Then you can apply load. So right now for this particular mechanism, I have applied initial condition just to drop that e-bike from certain height, and it's like I have applied it on a joint. So you can select marker or joint depending on your choice. I have selected joint, a planar joint, which will give me a position. I mean, I have defined position of 100 mm. I'm dropping this e-bike from 1000 mm height, so so that it can get it can bounce, it can hit the ground and bounce back. And after that, so in this particular assembly, you will observe that there is a suspension fork, and suspension forks are, I mean, there should be either a bushing or a spring or yeah. So I have defined dampers will be there. That means we, to define the dampers, we have cylindrical bushing. So here you can select the outer sleeve, inner sleeve, just to define the damper or the suspension thing. Damping, you can assign percentage of a stiffness. I mean, or if you are willing to have constant damping, then you can choose for this. Then there can be a free axial movement or free torsional movement, and accordingly you can have a stiffness and damping. So the shock absorbers are having stiffness as well as a damping coefficient. So you can add both the values for radial, axial. So
Hmm.
I have checked free torsion, that's why torsion is not there. But if you uncheck it, the torsion will be there. So all these stiffness related value and damping related value can be used for your shock absorber, and you can define that in your assembly as well.
That's pretty cool because I
Yeah,
mean
yeah.
that kind of stuff's like I mean as a mountain biker myself, I mean that's so important to be able to fine tune a lot of those details for sure.
Yes, yes. So these are the things you can easily, and most importantly, when I mean in other simulations for basically for structural simulation, I think there is a model check thing or scenario check thing. So just like that, we are having mechanism solve here. So once you are done with the markers and then defining joints, you can go to the mechanism solve, run the mechanism. If mechanism is working fine, then you can go ahead and define the initial conditions, contacts or
Mhm.
machine elements, or any load is there on the particular component of your mechanism. So it gives you that yes, you have properly defined mates or joints, so your mechanism is working fine. So just to have other components added on it, just to have a dynamic analysis of the whole mechanism, you can add mechanism solve. You can check mechanism solve and add those things.
Mm.
So under machine element, so using machine element only, I have defined bushings. But if your mechanism is having springs, you can surely go for this option as well. And after deciding doing this, you can create an analysis case and analysis step. So in particular mechanism, there can be several analysis cases, and in analysis case there can be several steps. So you can probably go for, in a single mechanism you can have a different motion analysis cases. Right now I just have one motion analysis case, but right here under scenario you will find if you have created a different analysis cases there in
So,
analysis. Yeah, go ahead.
so you could do, drops from different heights or something like that, right?
Yes,
Yeah.
you can
Okay.
you can do draw from different heights. You can change the combination of your dampers. I mean the
Hmm.
stiffness, spring stiffness and damping coefficient. You can change. You can vary on that. You can have a several compositions or the alternatives with your with you on absorbers. So
Hmm.
likewise in different mechanism there can be different things, different components, different parts. You may have uh, different choices. So with that you can play around easily within a single assembly.
Gotcha.
And in simulation only there is a command called run analysis case. When you click on that, it will automatically submit run on cloud, and within few seconds or minutes you will see the results. So right now I am having results open at me. I will show you directly. uh,
And so this is not necessarily an FE based. This is like a rigid body motion kind of simulation, right? So it's not doing like large deflection and things like that. This is a mechanisms simulation, like rigid body stuff, right?
yes.
Okay.
uh, just a moment. Yeah. Oh, it is there, but I was not able to.
That's why we do live, right? It's always fun when we can, right? So, yeah, I think everybody's been through this before. Try to give a presentation somewhere, and at least your computer's still up and running. So that's a good thing.
Yeah.
Um,
So this is the. It will take some time to open. So till then, I have a few things to talk about. So in XMotion design app, uh, so kinematics and dynamic analysis steps are there, cases are there, analysis steps are there. So kinematics is basically focused on movements where you will find that forces and momentum will be ignored. In dynamic steps, the the solver will consider movement caused by any force or moment. So in kinematics again, motion drivers control the mechanism, but in dynamics, motion drivers plus springs, gravity, force, or torque or inertial effects will be controlling the mechanism. So that's the difference between kinematic and dynamic step. So you are equipped with both the analysis steps. So you, depending on your end expectations, you can choose which step to add in your simulation. So this is the solved simulation. Let me play the result for you guys. So as I said, I'm dropping it from certain height. You can play it on loop and observe how things are changing. So you can clearly see that the suspension system is moving right away. You can change the stiffness and damping coefficient of it, and you can have a design variation at your end and analyze the motion simulation of it. So at the same time, as a result, you will get animation as well as 2D plots. So how 2D plots works? So for 2D plot, you can choose whichever dynamic step you are interested in, and then on element. So on body, on particular joint, or on a contact, or any machine element. So let's now I'm interested in that suspension fork. I will be choosing machine element, and what I'm so only it will again show you what kind of machine elements are there. So I have only one cylindrical bushing, so I'm selecting that, and it is asking what are you expecting. I mean, force or torque or displacement, angular displacement or velocity, angular velocity. So right now, let's say I'm expecting force output on the cylindrical bushing in XYZ direction. So go ahead and hit on add to plot. You will see that plot here.
So that's the force on the bushing from the drop.
Yes. So initial, it when it was releasing until
Yeah.
it hit the ground, it was, I mean, decreasing, and then the actual functioning of that cylinder
Mhm.
suspension fork start, and the forces are there.
Yeah.
So at the same time, you will see different color codes. So in y direction, the force is 0. So with the color contours, you can identify which one is the required force for your mechanism, and accordingly you can design your particular mechanism, or that part or the component or the joint maybe. Yeah, so that's it from my side on motion simulation.
Wow. So that's pretty awesome because I mean that really shows the how the dampening is taking
Yeah.
vibrations out. Um, is this something that you can then export these forces and put them into a
Yes.
based simulation and get all your stresses, your true stresses and things out?
Yeah, so you mean the actual stress induced due to mechanism on particular part or at particular surface?
Yeah, yeah. So now that we have this this force loading, can we put that into like some of our other simulations?
I think that's my future step to learn if
Yeah.
that is possible, and
Okay.
if
Yeah.
we can do that. Right now, I'm not aware of that, but I'm sure there is a way, and that should be included in the tool only. But I need
Yeah.
to explore that.
Yeah.
I'm not
I would
sure.
imagine if we could even just capture this
Yes,
equation
yes, yes.
or this in like an Excel spreadsheet or something, then I could bring that into a
Yeah,
simulation.
that's possible. You can export the result, but I think I let me show you how you can export it.
Yeah, this is pretty cool because I didn't know we could do
Uh,
mechanisms to this kind of level with all the damping and stuff in there. So that was pretty cool. Um,
I think I need to
Yeah. That's fine. That's fine. I imagine we can. And so yeah, so that's just kind of a fun part about this series, right? Like
Yeah.
totally unrehearsed. It's not just a bunch of questions that either one of us knows the answer to. And that's why
Yeah.
we like this series, is we get random questions that we can ask for each other or from the audience. So yeah, so that's it. Very good. Very cool. Again, for those watching the video, I didn't mention it throughout because I was totally engaged with this, because I've not played or experimented with this workbench at all. And so, but please remember to like and subscribe. Let us know how we're doing. Let us know what other kind of content you'd like to see. Share this amongst your colleagues and your friends, maybe some of your enemies. I hope everybody's enjoying this. It's fun for us. We get to explore some new things that we haven't tried before. We get to also learn some things. So yeah, it's been a great time. So with that, I think we've answered all the questions that have come in.